G'day and welcome to Riccardo's DIY. Today we're going to build an electrolysis rust removing kit using equipment that we've got lying around the workshop. You'll end up using this 1,000 different ways. Actually, you'll only ever use it one way, and that's to remove rust, but you'll use it 1,000 different times. So this is a worthwhile piece of kit to include into your toolbox. So please sit back and relax, watch the video, and remember to like and subscribe. You're going to have most of this equipment lying around the workshop. I'm using a 20-litre plastic container, so stick to plastic or glass and avoid any metal containers to hold your electrolyte. Power supply is next. You can get away with a phone charger. I intend to use a 12 volt 60 amp power supply. I'll show you how to make one, just leave a comment. Next up is our cathode connection rail. I'm using a bit of copper tubing that I've got lying around the place. The anodes need to be the same material as what you're going to be derusting, so it's going to be steel or iron. That's just a Rio bar that's been cut into 300mm lengths. The same as with the hangers. Now I hang from the cathode bar and I use steel hanging wire. Try and avoid copper if you can. You don't want to introduce another metal into your electrolyte. There we've got our washing soda. Pick it up from any supermarket washing aisle. The hangers are 20mm conduit hangers. Typically pick them up from the electrical section of your big box store, and then we've got a selection of fixings. We're going to prepare the cathode rail now. We're just using a piece of copper pipe that we had floating around the workshop, and we're going to flatten it so that it's a little bit easier to go through and work with, and that'll become apparent a little bit later on in this project. But you could use any conductive metal at all. Flat bar's now ready for fitting to our electrolyte container. Our opening is around about 300mm, and our bar is obviously just a little bit longer than that one there. So we'll mark up a 300mm length, mark it up, and then bend it to shape. Our vise makes another appearance, and as you can see, we're going to squash it down so I get the lines that we went through and marked. We're going to use a hammer to go through and hammer this down to around about 90 degrees. Doesn't have to be exact, but somewhere along those lines will be fine. To be quite honest, the copper's that soft that you probably don't even need to use a hammer. You can just bend it down by hand. The way that we've configured this particular kit is that we are going to drill some holes on our cathode rail, and then we're going to hang the items that we want to de-rust from those holes. The holes just make it a little bit convenient in that it'll stop the items that we've got hanging from moving and possibly touching the anodes. The holes that we're going to be drilling on this one here are around about 4 centimeters apart, but you can have whatever distance separating the holes that you like. It really will depend on the sort of equipment that you're going to be pushing through the machine. Final fitting, and as you can see, fits snugly across the container opening. We're using 20mm conduit plastic saddles as our anode supports. These are just going to be positioned on the corners of our electrolyte container, and they're purely there just to hold the anodes in place to make sure that they don't fall over and maybe make contact with the piece that we are removing the rust from. We're going to put some holes through the top end of our anodes, and then we're going to go through and flatten those ends with a grinder. This is an optional step. We are purely doing it because it makes it a little bit easier for us to be able to go through and make our electrical connections, and you'll see that a little bit later on in the video. This step is actually optional. We're going to grind the ends of the anodes just so we've got a couple of flat surfaces to be able to bolt the electrical connectors onto through the hole. This is where we're going to go through and do our electrical connections. So first thing we're going to do is just going to clean up our cathode rail and anodes just to make sure that there aren't any sharp edges that are going to cause us some grief a little bit later on. We're using electrical connectors that we're crimping onto some wire, and then we're going to bolt them to the anodes and the cathode rail. You could be really crude and just wrap some copper wire around those sections there. The anodes all need to be connected together so that we only need to apply power at one point, and the cathode will only have one connection anyway. The electrolyte solution is actually pretty simple to go through and make. We mix in between 5 and 10 grams of washing soda per litre of water. You can go to the additional step of using distilled water or demineralized water. We haven't on this occasion here, and the results that we're getting are more than satisfactory, certainly for the work that we want to go through and do. Unfortunately, we're a little bit off camera on this one here, but what we're doing is we grabbed a whole lot of rusty Allen keys that we found at the bottom of one of our toolboxes, and we're just wrapping the wire that we're going to use for our cathode rail, the hangers, around each of the pieces, just so that there is a good electrical connection between it and the actual cathode rail. Important to note here is that if your item is particularly rusty, then rust actually is an insulator. So if you've got a lot of rust there, you may need to hit it with a file just so that you can get down to some bare metal and make sure that the wire that you're wrapping around it makes good contact with that fresh area. And now to the part that we've all been waiting for, where we connect everything up and see whether the kit works. I mentioned earlier on in the video that you can actually use a battery phone charger to supply the voltage. In this case here, we've connected a car battery charger. Now, smart battery chargers nowadays will vary the voltage output between 4.5 and 12 volts. I measured this one here at various points and it was pumping out 4.5 to 8.9 volts and an amperage of around about 1.2 to 1.5 amps. As you can see, we are creating bubbles. Now the bubbles are actually hydrogen, so one point to be wary of is that hydrogen is highly flammable. Although in a normally ventilated workshop area, the concentrations of hydrogen are not going to be anywhere near enough to be able to cause an explosion. However, safety first, make sure that you have got maybe a fan happening in the background just to go through and move this hydrogen away from any sparks that might be caused by the equipment. In this part of the build, we'll connect our constant 12 volt 60 amp power supply. We would expect a more active rust removal process, and this will be evident by the increased production of hydrogen. Left long enough, we should also see a significant rise in the temperature of the electrolyte. Although the overall rust removal process will be significantly quicker, one of the reported disadvantages is that we'll produce a more porous base metal, which in turn will rust quicker if left unprotected. All items that have been through the electrolysis rust removal process, regardless of the power supply used, will need some mechanical cleanup. An anti-rusting coating of oil or paint will always be required, thereby eliminating the perceived porous metal issue. And here are our results. Using a small power supply unit, all rust was removed from our Allen keys within an hour. Using the large power supply unit, all rust was removed from our Allen keys within 15 minutes. As mentioned earlier, all the new pieces need to be rubbed down to remove any residue, and then an anti-rust coating applied. And we've gone through and given a light coating of oil. And there you have it. As you can see, this consists of a container to hold your electrolyte, some anodes, a cathode, and a power supply. Once you have added your electrolyte, you're ready to remove rust by electrolysis. Thanks for watching. We hope you enjoyed this video and will build your own unit. Please remember to like and subscribe or follow us on Facebook.